Hello everyone. For this video, we're going to be reviewing the Gang of Four design patterns. This name came from the four authors of these software design patterns, and these patterns are mainly split into three groups: structural, creational, and behavioral. Structural patterns generally deal with relationships between entities. Creational patterns provide instantiation mechanisms, and behavioral patterns are used in communication between entities and make it easier and more flexible for these entities to communicate. So why should we use these patterns? Because design patterns are by principle well thought out solutions to well-known programming problems. And many programmers have encountered these problems before and have used these solutions to remedy those. So if you encounter these problems, why recreate the wheel, reinvent the wheel, and not use an already proven very good solution? So this is about the Gang of Four patterns, and so far we have been discussing about the grasp principles that are reigning in good software design, and they have guided these patterns that you will be seeing, that we will be reviewing in this video. The adapter pattern is the first and quite well-known pattern that is solving the problem of bridging between incompatible interfaces. So this pattern can match interfaces of different classes. It's a very useful pattern, and it is a structural pattern since it combines the capability of two independent interfaces. So here's the classic case study from your book, your textbook, and it's the next generation point of sale that has to interface with third-party services, tax calculators, credit authorization, inventory, and accounting. And each one of these has a different API. And so that's why the adapter pattern is deployed. As you can see over here, there's an accounting adapter, a credit authorization service adapter, and so on and so forth. And then they can be specialized accounting adapters and specialized credit authorization adapters. So the adapter also is implementing the indirection design principle, and it gives some way of adapting to different external interfaces. Like you may want to adapt to an external interface of a database or a network, and so on and so forth. And the sequence diagram of the use of the adapter is shown in this slide, where the SAP accounting adapter is used to access the SAP system. And if, in case you didn't know, the SAP is a big statistics software, so you can Google it. It's a very interesting company. And so your software may have to interface with other software packages. And the adapter is the perfect way of doing this. Actually, I think the adapter many times as the outlet adapter that I use when I go to Europe, for example, and I use my US devices. So it really is something like an interface that makes the plug from US match with the European outlet. So here you can see that the design pattern adapter is using a lot of the grasp principles that we have discussed. It's an example of polymorphism, indirection, as I have already discussed, and pure fabrication. And this is a really nice picture that shows that also polymorphisms leads to lower coupling and indirection as well, and pure fabrication as well. And also pure fabrication can also help with high cohesion. So we have already discussed this thing, so it's a very nice visual in this slide. As you are moving forward with your software design and design patterns, you may have to update the domain model or with concepts that you may have discovered. And of course, you are definitely updating the class diagram, which will include the artificial artifacts that you may create because of design patterns and all that, such as adapter. The next pattern that we are reviewing is the factory pattern that was designed to maintain separation of concerns and really to create objects. So it separates the responsibility of creating objects into a cohesive helper object that is called the factory object. And it's created to hide complex creation logic, and it allows performance enhancing memory management through caching or recycling. An example of a factory is shown in this slide. That creates an instance of several families of classes. It is obviously a creational pattern, and it also abides by the protected variations design patterns, as most software artifacts do. The factory is also a singleton pattern, which means that there's only one object created of the factory class. And that brings us nicely to the next design pattern from the gang of four, the singleton pattern, which is really a way of ensuring that a class has only one instance and provide a global point of access to it. And the singleton also is parallelized with static methods and all that, a static global way of accessing a specific object. And in this slide, we can see the singleton pattern implemented in the services factory, where you may also have static methods. And so you know that static means that you don't need an instantiation of an object, but it also refers to a single object that can do can perform the operation that you want. And here we have some application of the singleton pattern. And you should ask yourselves also why we don't make everything static, actually. And it's because it wouldn't be polynomic, it would not polymorphic, it would not permit overriding, and static is not, and singleton is not really an object-oriented pattern. It's a necessity sometimes, but it's not the reason why we use objects and modular, pluggable classes. And in this slide, the three patterns are summarized: adapter, factory, and singleton. And you can see that the services factory is a single class that is creating an adapter, the SAP adapter that we need to access this package that called SAP, and that puts everything together for the three patterns that we have discussed so far. Next, we review the strategy pattern, which is a very interesting pattern where you apply things that you've learned at 30 about different algorithms and all that to software design patterns. So the strategy pattern defines a family of algorithms, encapsulates each one and makes them interchangeable. So let's say you have a family of sorting algorithms. With the strategy pattern, you could use any sorting algorithm depending on your application and what you want to achieve. So strategy lets the algorithm vary independently from the clients that use it, and it captures, it's almost like an interface. It buries implementation details, and it is a behavioral pattern. This slide shows an example of the strategy pattern where there's many sales pricing strategy classes, and there is a general strategy, pricing strategy, and then there's percent discount and all the different variations that could be. And with the pricing strategy, the pluggable pricing strategy, you can use any of those depending on the type of the customer. And here you can see how the pluggable pricing strategy can be any type of strategy. In this case, it's percent discount. You can also see a nice application of visibility, as the sale has parameter visibility, and it's passed to the strategy so that it's visible to it. So here you can see two patterns together, the strategy and the factory. If we need a method to generate pricing strategies, we may use the factory pattern. The composite is the next pattern that we're reviewing from the gang of four. It is used to compose objects into tree structures to represent whole part hierarchies. And the composite lets clients that treat compositions of objects uniformly. Um, it is a structural pattern, and when I think about composite, I think about directories containing other directories. So it's like a recursive pattern, and it's being composed, this pattern, by other similar classes. So it's a one-to-many relationships. You can also think the composite as a sum, as a composition of objects. And here's an example of the composite pattern. The outer composite object contains a list of inner objects. So you can see over there the composite pricing strategy contains composite best for customer or best for store. And in this slide, you can actually see clearly the polymorphic principle in the composite pattern, where the composite strategy may contain multiple different strategies, and that can be pluggable in this specific sequence diagram. And a little bit about UML notation, a little bit of a detail, but an abstract class can be shown with italics, as the composite pricing strategy is an abstract class. And then there may be implemented methods in the abstract class, such as the add method that is not italicized. And then you can see an abstract method, the get total, that is in italics. The next few sequence diagrams are good to review. I'm not going to say too much about those, but they're good to review and read in detail. They really show how the composite strategy is created and used. And we're moving to the next design pattern, which is called the facade. The facade is a front-end interface that hides the subsystem behind an object. Actually, the facade is used by you already if you're using JDBC. JDBC is a facade for interfacing with different types of databases. So it's a very nice application, the JDBC API of the facade pattern. And here you can see a nice example of the facade pattern, and you can see how the facade is used to separate concerns, which is a very nice design principle in general, a very nice computer science principle. We try to layer our software and hardware so that we can debug it better, understand it better, and all these good things. We have talked about layered architectures. You can see how the facade promotes this layered architecture style, and it provides a unified interfaces to a set of interfaces. It can wrap a complicated subsystem with a simpler interface, and that's the beauty of this design pattern. Last pattern of the day is the observer pattern. Let's at least review one pattern that has to do with interfaces. So this pattern is the view part of the model view controller framework. So it encapsulates the core components of an interface, and it defines dependencies when object states change. And we have said that state diagrams are very good for describing these state changes in a user's interface. So here's a little more detail on what the problem is that the observer pattern is solving. This is a behavioral pattern, and it is about subscribing in a way to a user interface and taking the input, or it is an event listener, really. So I really like this description, this word to describe an observer. It's an observer, it watches or it listens for triggers that come from the interface. So the property listener here is the observer that communicates with a frame. So we are learning JavaFX, so this would correspond to a scene and not a frame. The book is using Java Swing, for examples. We do not like Java Swing. So, you can substitute the sail frame with sail scene. And lastly, the sequence diagram for the observer design pattern, where you can see the property listeners listening for triggers from the sail frame user interface. Now here is maybe the most important part of this video. It's how you practice with these patterns besides using them in your project, which you will have to describe with labels, which patterns you have applied into your project design. You should also use the resources that I'm giving over here. The first four resources are quizzes on software design patterns, very useful to recap the materials. The last link is a very nice online book about design patterns with very good examples. So I strongly recommend that you take a look into that. And now you should be ready to take the Kahoot quiz that is posted on Oaks.